Good evening, everyone. Respected directors, deans, principals, esteemed faculty members, industry experts, distinguished guests, and dear students. A very warm and cordial welcome to all of you. It is both an honor and a privilege to welcome you to this international webinar on building secure and scalable systems, cloud, DevOps, and cybersecurity in the real world. Today's gathering brings together participants, academicians, researchers, and professionals from across India and several other countries, making this event a truly global platform for learning, knowledge sharing, and professional collaboration. In an era where technology is rapidly transforming every aspect of our lives, the importance of secure, scalable, and resilient digital systems has become more critical than ever before. This webinar aims to provide valuable insights into emerging industry practices, real world challenges, and evolving landscape of cloud computing, DevOps, and cybersecurity. We are delighted to have such an enthusiastic and diverse audience joining us today, and sincerely hope this session will be informative, engaging, and inspiring for everyone present. Now, I would like to respectfully invite our esteemed director, Dr. Dhanaraj, to kindly address the gathering and formally introduce the distinguished chief guest for today's session.
Yeah, thank you. So I welcome you all for this building secure and scalable systems, cloud, DevOps, and cyber security in the real world. So today we have a very distinguished resource person, chief guest, Dr. Merlin. So Dr. Merlin is an accomplished technology professional with a distinguished background in both academia and the IT industry. So, holding a PhD in computer science, she successfully transited from academia to the corporate sector and currently serves as a DevOps and a cloud specialist. Her areas of expertise include cloud security and architecture, API lifecycle management, and enterprise DevOps integration. So, Dr. Merlin is recognized for her analytical acumen, leadership, and commitment to excellence. Okay, now we are here to hear your valuable thoughts, madam. Thank you.
Yeah. So, am I audible?
Yes, madam, audible. You can continue.
All right. Okay. So, good evening, everyone, and thank you for joining this session and spending an hour with us on your Saturday evening. Much appreciated. In this session, we will connect three ideas that shape modern engineering: cloud, DevOps, and cybersecurity. Before that, thank you to the MC for the introduction. Special mention to Dr. Dhanaraj Shanmugasundaram, the founder and director of SecFork Tech Solutions. My best wishes for your team, sir, and also for your mission. So, as Dr. Dhanaraj mentioned, I have spent around 14 years in academia. After I moved to the USA, I shifted my career and I'm currently working in IT for the past 6 years. I get to lead and build and solve business problems using technology and AI. And I also get to work with C-suite and executives of some higher ed tech leaders across the nation. The main goal of this session is to show how software is built, delivered, scaled, and protected in the real world. So by the end, you may have a stronger mental model of how all these pieces fit together. I heard from the organizers that the majority of the participants are from second and third year students. Glad to welcome you all here. There might be some faculty members or industry professionals. Welcome you all once again. I hope there will be some takeaways for each of you. So let's get started. All right. So let me quickly walk you through what we will cover today. Each of these topics, cloud, DevOps, and security, is a large subject on its own. So this session is meant to give you a strong introduction and understanding. We will begin with DevOps foundations, where we will be covering why this DevOps exists, what is the mindset behind it, the life cycle of DevOps, things like that. Then we will talk about DevSecOps, and followed by we'll talk about cloud and scalability, and finally putting everything together with real world lessons. If you are new to any of these areas, that is completely fine. The goal is to build intuition, not to overwhelm you. We need a lot of sessions to cover all of this. But what I want to do today is mostly on introducing the DevOps and the DevSecOps concepts. Okay, so let me start with a question. How many of you have heard the phrase, "it works on my machine"? That sentence is basically the origin story of DevOps. Before DevOps, development teams and operations teams worked in complete isolation. Developers wrote code, operations teams deployed and maintained the systems, and the handoff between them was painful, full of delays, miscommunication, and environment mismatches. All of this happened. So one team would finish their work and throw it over the wall, and the other team would catch it and find the problems and throw it back. So this cycle gets repeated, and it leads to slow and frustrating and expensive task. So DevOps emerged to break that wall. The idea is simple. Instead of two separate teams with separate goals, you'll be having one shared pipeline, one shared responsibility, and one shared definition of done. So the key phrase here is speed with reliability. Not just moving fast, but moving fast without breaking things. Okay. Here is something important to understand early. DevOps is not a tool. You cannot install DevOps. Okay, it is a mindset, and mindsets are harder to change than software. So the three pillars are people, process, and tools. And in that order, people, process, and tools. People first, because the best CI/CD pipeline in the world won't help a team that doesn't trust each other or share ownership of outcomes. So think of it like a relay race. Okay, if each runner waits too long before passing the baton, the team loses, regardless of how fast each individual is. Okay, DevOps reduces those waiting points. We will see what are the different stages in the DevOps. So shared ownership means developers care about what happens after deployment. Operations team understand what developers need, and security, which we will get there shortly, becomes part of the engineering conversation, not the final checkpoint. Okay, so tools automate work, but they cannot automate teamwork. Okay, that's the mindset. So the real success of DevOps is not automation alone. It is collaboration plus automation. Okay, a small improvement in each sprint may not sound like much, but over the time, those improvements add up to a much better system. Okay, look at this diagram. So many of you would have seen this before, or this may be the first time you're seeing this diagram. Notice it is not a straight line. It is a loop, and that is intentional. Because software is never truly finished. You plan, code, build, test, release, deploy, operate, and monitor. And then monitoring feeds back into planning for the next cycle. That loop never stops. This is what separates modern engineering from the old models, okay, where you would spend months building something and only discover problems at the very end. In DevOps, feedback is continuous. If something breaks in production at 2 a.m., the monitoring system catches it, the team learns from it, and the next sprint is better because of that. Okay, so there is a term CI/CD, okay, that is continuous integration and continuous delivery, or we can call it as continuous deployment also. Depends on the projects, depends on the organization, on how they are doing. Okay, that CI/CD is the engine that keeps this loop moving. Okay, so continuous integration means every code change is automatically built and tested. You make some code change, you make some commit, it will be automatically built using any of the build tools. Okay, you might have heard about Maven tool, Gradle, Okay, tools like that. So if you do a commit, it will be immediately built and tested. So that part is called as continuous integration. Continuous delivery means the code is always in a deployable state. Okay, and continuous deployment means every passing change goes straight to the production. There is no human gate, whereas in continuous delivery, a manual approval is required. As I mentioned, it depends on the organization. It depends on the project needs, how your code has to go to the production. Okay, so the faster the teams learn from the production feedback, the stronger the product becomes. So that is the whole point of this loop. Okay, now that the lifecycle makes sense, the tools become much easier to understand. Okay, because you can see where each one fits. Here are some commonly used DevOps tools. It's not limited to this, definitely. Okay, we have a huge set of tools, huge set of concepts for DevOps. I have a slide for that, which might be useful for you. But yeah, to start with. So students during these kind of presentations or sessions, they often ask me, do I need to learn all of this? The answer is no, not all at once. What makes, to learn each and every tool, it's better you go layer by layer. Okay, so what matters more is understanding why each tool exists and what problem it solves. Okay, for example, Git is a version control tool. Think of it like a time machine for your code. Every change is tracked, every mistake is reversible, and multiple developers can work on the same code base without stepping on each other. Okay, I hope that you all will be having your own Git repository to store your projects. If you don't have one, please create one and start working on that. Okay, so Git helps in collaboration. For example, let's say several developers are working on same application or same API. Okay, how can we maintain the version? Okay, you want to roll back to some other version, you have done some mistake, you wanted to go back to some previous commits. So Git helps to do that. It is used to track every code change so teams can collaborate and roll back safely. Okay. And the next one is CI/CD tools. Okay, we have many tools for that. So tools like GitHub Actions, GitLab CI, they automate the build, test, and deploy the cycle. Okay, and we have something called Docker. It packages your application and so that it can run anywhere. It will run the same way everywhere. Okay, be it in your laptop or in your colleague's machine or in the cloud, wherever it is. Okay, and also there is called something called Kubernetes. Some of you might have heard about it already. Kubernetes manages the containers at a larger scale. And Terraform let you define your entire cloud infrastructure in the code format. Okay, so what kind of cloud you need to do, what is your VPC setup, what is your subnet setup, all that. Okay, how many vCos you want, all those infrastructure will be coded through this Terraform. Okay, so I just want to give a career insight here. There are engineers who specialize in just Kubernetes or just Terraform, and they are in very high demand. You don't need to master everything, but you do need to understand what each piece does and why it matters. Tools will change, concepts stay valuable. Okay, so we'll talk about these little more in the upcoming slides. I'll also cover a bit of the roadmap on which the students can learn DevOps. All right. So this is where DevOps stops being theory and becomes something you can actually build. Okay, the shift from the manual setup, server setup to automated, auditable delivery is significant. So in the old world, deploying software meant someone logging into a server, running commands by hand, and hoping nothing went wrong. In the DevOps world, the entire process is codified, automated, and repeatable. Useful principle here is if you do something more than twice, you have to automate it. Automation is the key. Okay, because DevOps means most of the jobs must be automated. Okay, so that is not a laziness, that is engineering discipline. So as I mentioned, Git tracks every change. CI/CD pipeline runs the builds and tests automatically. Infrastructure as code It means all your environments are defined in files. Okay, you cannot click something in the UI. Okay, all has to be through a code. And monitoring closes the loop after the deployment, giving the team visibility into what is actually happening in the production. I missed to cover this branching strategy. Branching strategy is another important concept. It depends on the team again. It depends on the projects. What should be the team's branching strategy? Okay, you'll be having a main or the master branch, okay, which is the source of truth, which will be having only your prod deployed code. And from the main or the master branch, you'll be cutting your release branch. And from the release branch, you can have several feature branches, and several developers can work on those feature branches. Okay, and there could be a develop branch, which is kind of a dirty branch where developers can play around. So there is this branching strategy is also very, very important. Okay, so yeah, so the result is lower risk at every release. That's the aim. So not because you're moving slower, but because every step is tested, tracked, and reproducible. All right. So let me give you a number that puts this in perspective. Okay. We all know with this DevOps, we'll be having 10 times of faster releases and almost zero manual mistakes. Okay. Better reliability because we have this monitoring in place, right? 24/7, and we have this alerting mechanism in place. So a bug caught during the CI testing might take 5 minutes to fix. The same bug discovered in production after it is affected the real end users can take days of engineering time plus the cost of the losing trust, right? So that's the business case for DevOps in one sentence. High performing DevOps teams deploy significantly more frequently than traditional teams. They have fewer failures. And when failures do happen, they recover faster because the systems are observable, the pipelines are automated, and the team has practiced the process. So DevOps is not just a technical practice, it is a competitive advantage. So companies that ship faster with fewer incidents will win in the market. Okay, and engineers who understand how to build those systems are the ones companies want to hire. Okay, so DevOps gave us speed, but here is the problem. Here is a problem, okay? Imagine if you're moving fast in the wrong direction, you get to the wrong place faster, okay? So that is where DevSecOps comes in. Traditionally, security was a gate at the end of the process, okay? The development team would finish building something, hand it to the security team for review, and wait, sometimes weeks, for the approval. By that, excuse me. By that point, fixing a security issue was expensive, disruptive, and often rushed. So DevSecOps changes that model. Okay, like it changes that model entirely. Instead of a final gate, security becomes a continuous thread woven through every stage of the pipeline. We call this shifting left, moving security checks earlier, closer to where the code is written, where the fixes are cheap and fast. The goal is not to slow down the things. It is to make the pipeline both fast and safe. Those two things are not in conflict. When security is automated and integrated, it actually speeds up the delivery by catching problems before they become production incidents. Okay. So this is one of the most important slides in the entire session. So I want to spend a little time here. So as I said, security doesn't start at the deployment. It starts at the very first planning conversation. During planning, we ask, what are the possible attack surfaces? How are systems communicating? Where do we need access controls? This is called as threat modeling, okay? Thinking like an attacker before the attacker does. Okay, then during the coding phase, developers apply secure coding standards, input validation, proper authentication, and no hard-coded secrets, careful dependency choices, things like that. And at the build stage, we have something called SAST, that is Static Application Security Testing. What it does, it scans the source code without running it. It looks for insecure patterns, any SQL injection risk, or any hard-coded passwords you have. Okay, think of it like a security code review that runs automatically on every commit. You are making just a commit, you are just doing some code, okay, and that commit is on some branch. Immediately the SAST will run and it will figure out if there is any such error, okay, any obvious error. And the test stage, we have something called DAST, that is Dynamic Application Security Testing. It probes the running application from the outside, the way an attacker would. Okay, it finds some runtime vulnerabilities that static analysis can't see. Okay, and at deployment time, secret scanning, dependency checks, and IAC scanning, infrastructure as a code scanning. So it will catch any misconfigurations before they reach production. And after deployment, monitoring continues, right? Because threats evolve and systems change. One thing I want to be clear about, in real teams, you are not writing these tools, SAST tool or DAST tool from the scratch. The industry has powerful tools available. Okay, we have a lot of tools for covering SAST. If you take GitLab, GitLab has its own SAST. Okay, we have so many tools like SonarQube, Veracode. There are so many tools we have. The real expertise is in understanding what each tool does, configuring it correctly, integrating it into your pipeline, okay, and reducing the false positives. So that knowledge is what makes you valuable. Okay. Now we have seen a similar diagram before. Okay, that is a DevOps pipeline, and this is a DevSecOps pipeline. Okay, so take a look at this diagram. This is what the concepts from the previous slide look like when they are actually running. Notice how security appears at multiple points across the pipeline, not just at one checkpoint. So on the left side, security shifts left. Checks happen early at the code stage and at the build stages. On the right side, shift right protections cover production monitoring, okay, like runtime protection and feedback loops, things like that. So every gate in this pipeline must pass before the next stage begins. That is the discipline, okay? Say, for example, if something fails here, it cannot go here. If something fails here, it cannot go here, okay? So if a security scan fails, the pipeline will stop. The team will investigate it, fixes the issue, and reruns the pipeline. No shortcuts to protection. So the feedback loops are just as important as the gates. What happens in production informs what gets checked earlier in the next cycle. That is how the pipeline gets smarter over the time. All right. So let me connect the previous slide to something real. Okay. So this is a real pipeline. From the production project. Okay, so what you can see here is it is a screenshot from a GitLab for a particular API. Okay, so this is how a pipeline look like. Okay, we can define our own stages, what we want in that pipeline for that particular branch. For example, this is a release branch. Okay, so in this release branch, I wanted to have all of these stages, and each of this stage can have one job or multiple jobs. Okay, and you can define your own stages, and you can define what you want for that particular branch, and we can easily customize a lot of things for the pipeline. You can define, as I said, you can define the number of jobs and things like that. So any properties can be specified in this .gitlab ci.yaml file. You can call out your CI/CD code base, which has all these rules and stages defined, your CI/CD code base. So here in this example, each stage runs automatically. Okay, build, test, security scan, QA, staging, or in some places they call pre-production, or non-production, they call different ways, and then production. And each stage has one job, okay? Either pass or fail. So the green check marks you see means this stage passed all required validations. The pipeline is allowed to continue. If anything fails, a security scan, a unit test, a configuration check, the pipeline stops immediately. That's a feature. It's not a bug. Okay. it's a feature. If some failure happens at any of the stages, it will stop. So we never want any unstable or insecure code reaching higher environments. So I'm okay to deploy up to QA, okay? And I'm okay to deploy up to stage, and I want to do the testing. And only if it passes, I want that code to be deployed to the production, okay? Not before that. Suppose if I have any failure stage here, I don't want that particular code to get deployed into production. Okay, so that's how we can make that security tighten. Okay, so yeah, yeah. Again, this looks visually very simple, right? But it has a lot of engineering behind it. Source control integration, build orchestration, containerization, artifacts management. Because after the build, you'll be getting the artifacts, and where those artifacts are to be getting stored. There are so many backend work going on here. And deployment strategies. How do I want to deploy? And which environment I want to deploy? And what are the security integrations I have? And do I have any monitoring for that? So all of it working together for this simple pipeline. Okay. So honestly, just understanding how a deployment pipeline works end to end, like from the first commit to the production, it could be its own full workshop. Okay, maybe that is something we can plan for a future sessions. Because seeing it hands-on, it gives a completely different level of understanding. Okay, as I explained before, the key principle on this slide is security feedback should reach the developers as early as possible. Okay, in wherever stage they are, it has to reach the developers, as fast as possible. So now let's see some of the tools for the security which developers can use. We have a lot of IDEs. I'm sure you are aware of many. I'm sure you are using many, like Eclipse IDE, Cursor IDE, and there are a lot of web IDEs also. Okay, so security plugins in the IDE, it gives a real-time feedback, like flagging insecure patterns as you type, like the same way how the spell checker flags the typos. Okay, when we do some typo mistakes, things like that, and pre-commit hooks. It will block the insecure code from even entering the repository. I can have so many pre-commit hooks. I can have a lot of rules written for that. So before even entering the repository, it will scan that. Okay, and inside the pipeline, we just saw about this static application security testing, dynamic application security testing, things like that, and this SCA, like software composition analysis, that checks the open source dependencies for any known vulnerabilities, and infrastructure as a code scan. Okay, that will review Terraform and Kubernetes configurations or any misconfigurations happened. So the earlier any problem is caught, the cheaper is to fix. That's the whole logic of shifting left. And these tools are what makes it practical. I've been continuing to talk for a long time. I hope I'm audible. If anybody can tell me that, some acknowledgement, it would be good. I'm audible and you are able to see the slides. Can I get some acknowledgement? All right. Okay, I see some thumbs up. Fine. Fine now. Once code leaves the developer's environment. So in the previous slide, we saw how the security can happen at the dev environment itself, at the developer's place itself. Okay, once code leaves the developer's environment, again, the security checks don't stop. They continue through every stage of deployment. Okay, think of it like a airport security. You don't just check passengers at the entrance. There are checks at the gate, on the jetway, and sometimes even on the plane. So multiple layers, each catching something the previous one might have missed. Okay, so similarly, container scanning checks the Docker images for any known CVEs, that is the common vulnerability and exposures before they are deployed. And DAST, that probes the running application in staging from the outside, the way an attacker would try to approach it. And runtime protection monitors workloads in the production for suspicious behavior after going live. So not every vulnerability, the problem here is not every vulnerability appears at build time. Some only show up when systems are actually running under real conditions. So that's why the checks continue all the way through. Okay. Again, in real teams, all of these are combined into one continuous pipeline. So security is always on. It is not occasional. Okay. Almost a repetition here. So before you run your first pipeline, you need to be comfortable with these terms. You will encounter all of them on the job, okay, in your job descriptions, in code reviews, peer reviews, or merge request. Okay, these are different terms. Okay, different tools are using different terms. If you are using GitLab, so they call it as merge request. Okay, you are writing a code. You want that to be reviewed by another peer, maybe by another developer or by a lead. So that's called as a peer reviewing. Okay, so they will see that, and you want to get an approval for that code to be merged to the main branch or whatsoever. Okay, whatever your branching strategy is. So or in so many places you'll be seeing this. Okay, you don't need to memorize every detail right now, but you should recognize these terms and understand what risk each one is designed to reduce. As I mentioned, SAST, static code analysis, which scans the code without executing it. DAST, dynamic analysis, which tests a running application from the outside. So secret scanning finds the exposed credentials in your repositories, like API keys. Why I'm repeatedly telling this, you will understand in the upcoming slides. So API keys, passwords, tokens. So before the attackers do, secret scanning will find these things. Okay, and IAC scanning reviews your Terraform or Kubernetes manifest for security mistakes before they reach the cloud infrastructure. So these are the basics that show up repeatedly in the real projects. And there is something called multi-factor authentication. Okay, you want stronger authentication. Okay, so I'm sure we are using that multi-factor authentication for many other applications. When you want to log into some of the payment gateway or any of the other banking gateway, or take any application for that matter. So multi-factor authentication is important. Another thing is RBAC. You might have heard this term, role-based access control. So role-based access control, what kind of role can be given to this particular user? Okay, so identity and access management, there is something called IAM. Okay, so who is authorized to do what? You might have studied in your curriculum, in your network security or in your security paper or in your cryptography and network security paper, you might have studied a lot of these concepts, but where it comes to play, okay, in the real world applications. So DevOps is one such area where you have to really take care of all of these things. Okay, and cyber security is another thing, which is like, core security concepts alone. DevSecOps is like having security concepts and automation and pipeline management and Terraform, Kubernetes, everything. Okay, so a habit I would recommend is, whenever you hear a new security term, okay, ask yourself, what problem is this solving? What could go wrong without it? That question will take you a long way. Fine. So if you want to remember only a few things from the DevOps session, remember this. DevOps is a loop. It is not a line. DevOps is collaboration plus automation. So here, culture matters more than tools. That too, with today's AI world, we get tools every sprint, and people are practicing MLOps already, AIOps. Okay, I'm talking about DevOps, and already we have MLOps and AIOps in practice. Okay, but the base concept remains the same. Okay, how you are going to do that, it may change here and there, but this is the base. You need to understand that. Okay, so but as I said, you have to understand what each tool is doing. Security must be integrated continuously. We talked about it. And if you want to learn, do it in layers. Go with Git, go with CI/CD, go with cloud, any cloud, and go with the DevSecOps build on each other, okay, on top of it. So real progress comes from practice and small wins, not from trying to learn everything at once. All right. I just want to know how much time is left. Let me quickly check that. We have around 20 minutes. Okay. All right. We have covered DevOps and DevSecOps. Now let's zoom out to the environment where all of this runs, the cloud. So cloud is not just someone else's computer, though I have heard that joke more times than I can count. It is a fundamentally different operating model that changes how teams design, deploy, and protect systems. And the three ideas I want you to carry through this section are simple. Cloud gives you scale, okay? The scalability, term scalability, okay? DevOps gives you speed, and security gives you trust. Real engineering is about balancing all of these three. So systems are fast, resilient, and safe. So with that, we'll get on to this. So in the simplest terms, cloud computing means renting technology or resources instead of owning them. Instead of buying your physical servers, configuring them, maintaining them, and eventually replacing them, you just provision what you need and give it back, use it and give it back when you are done. Okay, you pay for what you use. So this changed the industry dramatically. A startup today can go from idea to global scale without building a single data center. That would have been unthinkable 20 years ago. So the four main categories are compute, which has this virtual machines, containers, serverless functions, and storage, where we have your object buckets, databases, block volumes, and other storage facilities. Networking, which covers the virtual private clouds, load balancers, your CDNs, that is your content delivery network, domain namespaces, and some of the managed services like queues, RabbitMQs, cache memories, ML platforms, and different monitoring. Okay, so your team can focus on building products instead of managing the entire plumbing. Okay, so the core benefit is teams move faster, scale when demand grows, and pay only for what they use. That is the foundation on which this modern DevOps and security operates. Okay, so that's why I just want to connect DevOps, then security to the DevOps, that is DevSecOps, and you want to deploy all of this and you need a cloud environment for that. So that's what we are covering here. Okay, the shared responsibility model. So this is one of the most important concepts in cloud security and one of the most commonly misunderstood also. Here is the simple version. The cloud provider, they secure the cloud. You secure everything you put in the cloud. Okay? AWS, Azure, GCP, or PCF, that is Pivotal Cloud Foundry, any cloud, they are responsible for the physical data centers, the hardware, the hypervisor, global network, everything. That is their job. They will do it well. They do it well. But the moment you deploy an application, configure a storage bucket, create an IAM role. IAM is that identity and access management role, right? Or write a line of infrastructure code, that's your responsibility. If you expose these credentials publicly, that is not AWS's fault. If you misconfigure a storage bucket and expose customer data, that is on your team. Okay, a simple analogy is something like the cloud provider secures the building, your team secures the rooms, the keys, and the valuables inside that. Okay, so many of the biggest cloud breaches in history happen not because the cloud provider failed, but because a customer misconfigured something. Understanding this model is the first step to not becoming a cautionary tale. Okay, here is your scenario. Your application launches, it gets featured somewhere, and suddenly you have 10 times the expected traffic. Does your system handle it gracefully or does it crash at the moment of success? Scalability is designed for this. The goal is to serve 10 users or 10 million users without rewriting your architecture. That requires thinking about distribution, redundancy, and automation from the very beginning. So, load balancers, if you have not heard of, it is helpful for balancing the load. It depends on how much traffic you are getting. It will spread the traffic so that no single instance is overwhelmed. Okay, horizontal scaling, it means adding more instances rather than bigger ones. It is more resilient and most cost effective also. Okay, and auto scaling provisions and deprovisions the resources automatically based on real demand. For example, I'm working on some mule applications. Okay, so I'll be allocating, they call it as vcores and replicas, the same memory, processor, whatever it is. Okay, so I am allocating one vcore and two replicas for a particular API. But then the load increases, the traffic is getting more. So that one vcore and two replicas will become one vcore and four replicas. And again, four replicas may become eight replicas, depends on the traffic. Okay, let's imagine it's a peak hour. Okay, it's a peak hour or a business hour, peak business hour. Okay, so I'm working on a higher ed tech business. Okay, so that means students will be active in the evenings. So that time, if they all are logging into the Canvas system or any of the LMS system, or you can imagine any of your online application, online buying system. Okay, during those peak hours, the traffic increases and the auto scaling has to happen. And once the traffic is gradually becoming low, then it will downscale. Okay, so that is very important when you are designing this, right? And caching, it serves like a repeated reads from the memory instead of hitting the database every time. And multi-zone design, it spreads your system across availability zones, so a single failure doesn't take everything down. Okay, these all are coming under some disaster recovery things, but still it's good to learn. So the lesson here is a well-designed system keeps working when the traffic spikes. It doesn't crash during success, like when the business is getting successful. Okay, good architecture planning matters yearly, and retrofitting scalability into a system that was not designed for it is a painful and expensive task. For example, whenever we touch some legacy applications and we want to add scalability to that, auto scaling to that, older applications, but that older application is still running somewhere for some purpose, and you want to add auto scaling to that, it's really difficult. It's tough. So retrofitting is tough. So when you are designing that, you have to keep these things in your head. Fine. Let me put some real numbers on the screen here, because sometimes the best way to understand why security matters is to see the scale of what is at stake. Okay, 94% of the enterprises are running in the cloud. That means essentially everyone. And cloud has become the primary attack surface for the entire industry. And statistics says that the average attacker breakout time is now 29 minutes. And the fastest is only 27 seconds. That was AI assisted attack. Okay, so with AI, we see the hackers are also getting stronger. And 80% of the organizations experienced a cloud breach last year. This is not a small, 80% is a staggering number. 68% of employees are using unsanctioned AI tools, which is called shadow AI, in case you don't know. Like employees tend to use it without their organization's knowledge or approval. Okay, and 97% of the AI related breaches involve systems that lacked proper access controls. We talked about it little earlier, the role-based access controls, the IAM features. So all of these are very important, and look at the money getting involved just for this breach cost. Okay, it's a big number for one organization. I'm not sharing these numbers to create fear. I'm sharing them because understanding the scale of the problem, and it is what motivates good engineering decisions. Okay, the rest of this section is about how to close these gaps systematically with the right controls. I have another 7 more slides, but I have 10 more minutes. Okay, I will try to skip few slides probably. Okay, so can I skip this by any chance? All right, so here is something that might surprise you. Most cloud incidents are caused by sophisticated nation-state level attackers exploiting zero-day vulnerabilities. They are caused by configuration mistakes, okay, and identity errors that were entirely preventable. For example, an S3 bucket, storage bucket, if it is set to public by accident, an IAM role with admin permissions granted, just in case if we need that, things like that. An API key committed to a Git repository. So even a private one, okay? And a container image with known CVEs sitting in the production because nobody set up scanning there. So in each of these cases, the application code was fine, but the vulnerability was in how the system was configured and how the access was managed. Okay, but this is actually good news because configuration mistakes are teachable and preventable. So engineers who understand this are significantly more effective at preventing the breaches than those who think security is someone else's job. Okay, small configuration mistakes can have large consequences. That's the pattern we are seeing. So for every risk we just discussed, there is a well understood control. Okay, so one is the least privilege. Every identity, human or mesh in any service account, gets only the permission it actually needs, nothing more, and audit and rotate it regularly. Then we talked about this multi-factor authentication. Okay, on all the accounts, especially those with the cloud console or pipeline access. This single control eliminates a huge category of credential-based attacks. And secret management use the dedicated tools like HashiCorp Vault or AWS Secrets Manager or GCP Secrets Manager. Okay, never store your secrets in your environment files, never in the GitLab, never in hard-coded in your source code. Okay, and logging and monitoring, you cannot defend what you cannot see. So you need those logs. So those centralized logs, audit trails, and alerts, all these are foundational, not optional. Okay. And continuous vulnerability scanning, containers, dependencies, IAC templates. So all these need to be checked automatically before they reach the production. These are not advanced features, they are the baseline. Okay, a strong team applies them consistently, not only after something goes wrong, but from the beginning. Maybe I can skip this. Okay, so here you can see how this real world cloud architecture looks like. So you have this identity and access management rules, multi-factor authentication, what are the different service accounts, things like that. And all this auto scaling, health checks, containerization of the applications in another block, data tier, and perimeter and network like all your VPC in the cloud and monitoring things, all this. Okay, so let me leave you with 4 things I want you to remember. Cloud is a shared responsibility. We talked about it. The provider protects the infrastructure. You protect everything running on top of it. Identities, data, configurations, code, everything. Okay, never assume the cloud is automatically secure just because a major provider is running it. Okay, your cloud provider can be AWS, your cloud provider can be GCP, any Azure, whatever. Okay, but don't just assume that it will secure. No. And design for the scale from day one. Okay, horizontal scaling, stateless services, and multi-zone design, or it's not premature optimization. They are how reliable, that is how the reliable systems are built. Okay, as I mentioned, retrofitting the scalability is painful. So when we touch some legacy systems, we want to introduce this auto scaling, it is painful. So building it from the start is professional. And security is part of engineering. So least privilege, MFA, secret management, these are engineering disciplines, not the task you hand off to a security team at the end of the sprint. Okay, and automate everything auditable. I mentioned in the first few slides, automation. You need to automate everything, okay, as much as possible. And so that the CI/CD pipelines, IAC, policy checks, artifact signing. So all of this make your delivery fast, repeatable, and trustworthy at the same time. Okay, so fast systems without security are risky. Secure systems without scalability will fail under the growth. Okay, if your business is growing, if you don't have a scalability, it will fail. Okay, and scalable systems without this operational discipline, it will become unstable. So you have to balance all of this. Okay, so I know this session covered a lot of ground. So let me give you a practical answer to the question I get most often. Where do I start? Don't try to learn everything at once. Technology can feel overwhelming, especially when every week brings a new tool, a new framework, a new acronym. The engineers who succeed are not the ones who know everything. Okay, they are the ones who learn in layers and build on each foundation before adding the next. Start with Git and Linux basics. These are the bedrock. Everything else builds on them. Then learn CI/CD and Docker. Understand how pipelines work and how containers package the applications. Then add one cloud platform. It could be any cloud. Okay, depends on what is available to you, what is easy for you. Okay, you have GCP access. If it is cheaper to get it, do that. Or AWS or Azure, do it. Okay, and then Terraform. Then layer with DevSecOps like SAST, DAST, IAC scanning, security scanning. We learned all of this and build small projects at each stage. Real learning happens through practice, not through watching tutorials. Okay, so break things, fix them, and understand why they broke. This will help you learn better. This is one detail I got from one of the source, Eyes on Cloud DevOps Engineer Learning Path. They gave some 20-stage learning path. And in the right-hand side, you can see some key tools and the concepts. Is it all DevOps? No, it's not just this. We have a lot, okay? So, but you can start with this. You can learn this Linux fundamentals. You can learn this networking basics. As students, whichever curriculum you are following, whichever university you are doing your education, I'm sure you are learning most of them. All you have to learn is where it is getting applied, how it is getting applied. Okay, you might know all the Linux concepts, you might know all the networking concepts, you might know all the security concepts, how it is getting applied, how industry is adopting to all those things. Okay, so yeah, so I thought I can share this. We have time. So yeah, thank you everyone for your time and attention today, especially on a Saturday evening. I hope this session helped connect the dots between cloud, DevOps, DevSecOps, and cybersecurity in a way that feels practical and real, not just theoretical. If you have any questions that didn't get answered today, or if you want to continue the conversation about your career paths or specific tools or anything we covered, feel free to reach out on LinkedIn or by email. I'm happy to connect. And I'll leave you with one final thought. Technology changes quickly. New tools, new platforms, new threats that will never stop. But the ability to learn continuously, to adapt, and to understand why things work the way they do, that will always be your strongest skill. Okay, so keep building, keep securing, and keep learning. Okay, thank you, everyone. Let's keep our learning curve progressing. Thank you.
Thank you very much, ma'am, for the highly insightful and informative session. Truly appreciate the valuable time, knowledge, and expertise you have shared with us today. Your thoughts and real world insights on cloud, DevOps, and cybersecurity have truly enriched our understanding and inspired all the participants present here. On behalf of everyone gathered here, we extend our heartfelt gratitude for your wonderful presentation and for making this session both engaging and impactful. We will now proceed with the question and answer session. Participants who would like to ask a question may kindly unmute themselves on Zoom. For those joining through YouTube or for participants who prefer not to speak directly, we request you to kindly post your questions in the chat box. The questions will be taken up and addressed accordingly. Please feel free to ask your questions without hesitation. We encourage active participation and interactions from everyone. Please feel free to ask your questions without any hesitations.
Any questions? Did you like the session? Can I hear some yes or no? some improvement feedbacks which I can follow in the next
It's very
session.
informative session.
Was it informative? Glad to hear that. All right. So if there are no further questions, can we wind off the session?
Madam, thank you for the wonderful session, madam. The thing is, some of the participants, they are asking their doubts in chat window.
Oh, okay. Let me
Okay,
see.
yeah, yes,
Give me a
yes.
minute. Sure. Is branching in Git how open source projects work? So branching in Git, yes, you can take that way. Okay, suppose if you are contributing to the open source project, and open source project, many people will be contributing to that, right? So you will be adding your commits, and the other person will also be adding your commits. And which version has to go for a deployment, or which version has to go for the patch release or a newer release, minor version, major version, you can relate in that way. Okay, but in a real world application, in a real world industry projects, there will be some branching rules set up. Okay, like maybe you must be having one main branch, which is your source of truth. And from the main branch only, you can cut your all other branches. That could be one branching policy. Okay, similarly, depends on the institutions, the branching policies can differ. But how you have viewed that is the right way. Okay, how you are contributing to the open source projects when others are also contributing, that's a similar thing. Okay, but industry projects, it has its own rules. That's all.
Ma'am,
Nisha, I
I've got
hope I have
another
answered.
question from YouTube chat. Can I read it out for you?
Yes, please go ahead. If I know the answer, I will answer it. If I
Yes,
don't know
ma'am.
it, maybe I'll come back.
Yes, ma'am. How we can enter into the cybersecurity in the evolving digital world?
How you can enter into the cybersecurity job wise, if you say, you have some security certifications. When you talk about the certifications, we have professional certifications. You can take those certifications, and the professional bodies are offering a course. Okay, you can go with those courses and take those certifications. And the other ways, if you are really interested, I don't know, you want to get into the job or you want to get into the research side. Okay, we have a lot of research papers in the security side. For the past 20 years or 30 years also, this security, it's like an evergreen topic. Okay, you can read through many research papers, you will understand a lot.
Ma'am, we've got another question in our chat.
Go ahead.
Yes, ma'am. How do you think AI will transform DevOps over the next 5 years, ma'am?
It has already transformed. Okay, it has already transformed. I have talked about you have your build stage, you have your unit, I mean the unit testing, you have your code quality. Okay, now we have a lot of agents taking care of this job. Okay, now what I'm doing in my job, though some of the legacy systems are still having this kind of a pipeline, I'm also working in the AI. So I have to write an agent which will take care of the entire CI process, which will take care of the entire CD process. Okay, in the next 5 years, there may not be the term DevOps. Okay, we may call it like AI ops or ML ops. The terms may change, but already we are seeing this AI's influence in almost every field, right? So same way in DevOps also there will be influence. But as I said, the foundation, the fundamentals, it's not going to change. Okay, so it's worth learning the fundamentals and worth being strong in the fundamentals. Then any AI tool comes, it's okay. You will understand, okay, so all these jobs will be taken care by this particular AI tool or this particular AI agent. Now I am writing agents. Okay, so that is how it will take care.
Thank you, ma'am, for that very detailed answer. Can I read out the next question for you?
Yeah, go ahead.
How does unauthorized AI used by employees affect security?
Okay. So unauthorized AI. You know, all the organizations, we are encouraged to use AI. We are encouraged basically, but we are encouraged to use the access provided by the organization. Okay, so when you are using some unauthorized, for example, I'm not supposed to use public chat GPT. Okay, but if I'm giving my entire code, what will happen? I may leak some data to that public AI, right? So that way the security is compromised. So that is how it affects the, when I am using the AI, which is something I'm not supposed to use, I'm doing some data leaks there. Okay, so that is how it is affecting the employees. Next question.
Thank you, ma'am, for that answer. I'll read out the next question. If
Sure.
DevOps is intended to break down silos, why do many organizations still struggle to implement successfully?
So yeah, DevOps intention is to break down the silos, right? We don't want the vertical silos like this is developer team, this is security team, this is operations team. We want to break down that. But we have a lot of applications which are already created. Okay, now we are talking about we should have one common pipeline where the developers team should contribute, the operations team should contribute, the infrastructure team should contribute. Practically, if you take any legacy applications, it's not that easy. If you remember in the first slide, I talked about the mindset. DevOps is a mindset. Okay, so it is not easy to change that culture in a day, in a week, in one sprint. It's not possible. But slowly, organizations are moving towards that. Okay, they are breaking that silos.
And that would be our last question. With that, we conclude the question and answer session. Thank you, ma'am, for your insightful session and for sharing your valuable expertise with us today. We truly appreciate your time and guidance.
Thank you, everyone, for your patient listening and your time. Thank you, Dhanaraj, sir. Glad to meet you here once again.
Yeah, thank you, madam. Thank you for the wonderful session. So I will share the feedback with you, madam. Thank you.
Sure, sir. Yeah. Thank you all.
Thank you.
The feedback link for the certificate registration has been shared in both Zoom chat and YouTube chat. We kindly request all the participants to copy and save the link immediately, as the chat messages will no longer be accessible once the meeting concludes. Please note that we will not be able to share the feedback link again through our WhatsApp group or any other platform. Therefore, we request you to kindly verify once again that you have copied the correct link. The feedback form will remain active for only the next 20 minutes. Participants are requested to complete and submit the feedback form with this time period to be eligible for receiving the participation certificate. I repeat, the feedback for the certification registration has been shared in the both Zoom chat and YouTube chat. We kindly request all the participants to copy and save the link immediately, as the chats will no longer be accessible once the meeting concludes. Please note that we will not be able to share the link again through our WhatsApp group or any platform. Therefore, we request you kindly verify once again that you have copied the correct link. The feedback form will remain active for only the next 3 minutes. Participants are requested to complete and submit the feedback form within this period to be eligible for receiving the participation certificate. Thank you very much for your cooperation. As we come to the end of today's international webinar on building secure and scalable systems, cloud, DevOps, and cybersecurity in the real world, I would like to express our sincere gratitude to everyone who contributed to the success of this event. We extend our heartfelt thanks to our esteemed chief guest, Resource person Dr. Singoli Mohan for sharing her valuable knowledge, practical insights, and professional expertise with all of us. The session has truly been enlightening, informative, and inspiring. We also express our sincere appreciation to our respected director, dignitaries, faculty members, industry professionals, coordinators, and organizing team for their continuous support and guidance in making this webinar successful. A special note of thanks to all the participants who joined us from different parts of India and across the globe. Your active participation, interaction, and enthusiasm made this session highly engaging and meaningful. We hope this webinar has provided you with valuable learning experiences and deeper insights into the rapidly evolving domains of computing, DevOps, and cybersecurity. Once again, thank you all for being part of this wonderful journey. We look forward to meeting you again in our future programs and knowledge sharing initiatives. Wishing you all success, good health, and a wonderful day ahead. Thank you.
So, thank you, participants. Dear YouTube listeners, please see the chat. Please verify the chat. Trailblazers Cube, that is the ID. Share the feedback link. It is already available. Nearly 20 times we posted the link. Please check. Please check the chat window. So, because if we close this live, it won't be available. Kindly copy the feedback link from the YouTube chat window. Once again, we will post it. Please check. Yeah, once again, we posted. Please check Trailblazers Cube. From this ID, we posted feedback link in YouTube chat. Yeah, once again, I'm posting. Please check Trailblazers Cube. That is the chat name. Check your chat window. Because the link is available for another 20 minutes. Please post your feedback. Right. Thank you. Thank you, participants. Thank you.
Sir, it seems like the link is not visible in YouTube chat, sir. Participants can kindly leave the meeting